Okay, so this is an interesting lab that is not directly tied to a lecture, but it really brings some good ideas on performance, on scaling. So let's go through it. So it mentions ACE is experiencing poor performance between BU1 front end and BU2 mobile app. So there is no connectivity problem, but there is a performance issue. So given the instance size of these workloads, they expect better throughput. So we need to check whether the gateways need to be resized. So that's an interesting question that, you might face in a production environment. So let's see what are the things that we can infer by looking at the problem. The first thing I will do is I can go topology, and I want to know first if the instances themselves, BU1 front end and BU2 mobile app what's the size of the instance? So I go again topology. This is the BU1 front end, and I look at the instance size. Oh, it's a C5N X large, which means they have enhanced networking. So generally, we should not expect any problem on the throughput from the instance perspective. Let's look at the instance of BU2 mobile app. Again, if we go down, we see that, oh, the instance is also a large one. But if we look at the gateway sizes, that could be something that this is what the question is about. We can see that the first gateway is in spoke 1 is a T3 micro, and the second one is also a T3 micro. So the question again, if just to be on the same page, is that do we need to scale up the gateways, or do we need to resize the gateways to be more accurate? So now the other thing, just want to bring up your attention because we are in AWS. There is an article on how much performance can you expect from different instances. So these are the hardware specifications, the number of CPUs. It's not what I'm interested in. So this is the network performance. So if I go and search for a T3.micro, and not the hardware, but yeah, this is what I'm looking at. So these T3 instances specifically are burstable instances, meaning that they allow you to burst up to a certain amount, but they're not able to sustain that amount. So the baseline bandwidth is what you're able to sustain, and the burst bandwidth is what you are able to get up to. Okay, again, they follow a token bucket algorithm where tokens are put into the bucket at a certain rate. And again, when you no longer have tokens in the bucket, you are going to go back to the baseline throughput. So again, the T3 micro instances can go up to 5 gigs, but they can sustain 64 megabits per second. Okay, so that is interesting to know. So the instances themselves, the workloads are good, but the gateways are only able to deliver 64 megabits per second at a sustained throughput. Okay, so can we do anything to try to see what's going on? So if we go to performance, let me close this one. And if we go to performance and we go to look at AWS, again, I'm going to choose spoke 2. I can do the same for spoke 1. So I am looking at this spokes metrics. So I am going to say I want to look at the received rate, how much I'm receiving, and I'm looking at bandwidth limit exceeded rate. This shows if there are any packets that are not able to be catered for by the instance, because when you are having a burstable instance, when you want to reach baseline, it means there might be packets that are coming to the network adapter, but the instance is not able to actually take those or ingest those. For the interface, I will choose Ethernet 0, and then I will say, you know what, give me the last 60 minutes, and I can apply. This is very, very interesting, and this is in line with what we were seeing before. So the instance was able to get up to 1 point something gigs, 1.27, which is again in line with the burstable idea, the logic of bursting. But then the instance goes down in performance and is delivering around 61 megabits per second on a sustained throughput, okay? Which shows that there is a problem, right? We were pushing so much whenever we had the tokens in the bucket, and then when we lost them, the throughput went down heavily. The other one is the bandwidth ingress limit exceeded. These are the basically the packets per second, packets that were arriving at the network interface, but they cannot make it into the instance. And you can see that these are packets basically that were actually dropped. So this shows us that these gateways actually are not able to deliver the performance required and are actually dropping packets. They're actually dropping packets, and thus might need to be scaled. The other piece, I just want to show it to you from a to bring the full picture together, is I already created a scaling policy for these gateways. And if you look at it, I said these are the two spokes. Again, the ones that are in question, spoke 1 and spoke 2. Going back to diagram, spoke 1 and spoke 2. And I mentioned if the metric is the bandwidth ingress limit exceeded rate, this again denotes the fact that packets are basically being queued and dropped. And if it's exceeding 0, meaning that I'm having this condition for a period of 10 minutes, then please give me a recommendation to scale up. Okay, again, scaling up is about vertical scaling. So this was the policy I put. And then what I wanted to show you is I am receiving a recommendation to where the condition actually happened, and I can see the recommendation to actually scale up. So I can click on this, and it's showing me that the metric has been exceeded. And if I want to scale up, I am able to click on that particular instance and choose a bigger instance size and basically begin the scaling operation. Okay, and you can see now the resizing is actually happening. Again, once it completes, this will be an event. I hope this was useful in the fact that, number one, we are able to view the instance sizes of all the instances, our gateways and the non-Aviatrix components, and how we're able to monitor the different metrics and visualize them. And the other thing is basically how we're able to tie it to scaling. And by the way, one more thing is, I think I've touched on it, but whenever you're configuring global network health, you can even create part of the metrics to say, hey, if I'm having any dropped packets, track that exact metric. Just want to show it to you. Bandwidth. Okay. Okay, sorry, I think I was mistaken. That particular metric is not there. So, or am I mistaken? 1 second, let's say all gateways, let me check. And bandwidth, yeah, exactly. So now that you go to the alerts, you can define that's the exact metric that we were leveraging, and you can enable it for all gateways whenever you have drop packets. This particular metric works in AWS, just as a matter of fact. And again, you need to decide how long you want to evaluate this thing for and who are the recipients of that alert. Okay. So this, again, gateway resizing is going to take time, but I hope this gives a good idea on performance, on monitoring, on scaling, on alerting, and this concludes the lab on gateway scaling. Okay, I just thought before I close this one, I just want to show you that the scaling event actually happened. So you can see that the gateway was actually resized. We're talking about the spoke one. And again, if you go to gateways, for example, spoke gateways, and if I add the instance size, you can see that these two gateways, whenever we started, both of them were T3 micros. I just allowed the scaling of the spoke one, and this is where you can see T3 medium versus T3 micro. So this is recorded as part of the events. Notice that there was another one for spoke two, but this one is no longer valid because the metric went back to being within the limits. Okay, I think this is a better conclusion now that you see the scaling action actually happening within the lab. Okay, thank you.